Conspiracy Journal podcast. The transmission starts now.
Let's talk about space, baby.
Ooh, space.
Let's talk about space, baby.
I mean, I really obviously love aliens. You know, very, very fascinated by that. And in looking for topics to do or thinking about things to do, it's really easy to get stuck on planet Earth.
Yeah.
You know? And
Yeah, for sure.
What how flat it is.
That's right. That's right. Because it's so flat, it's really easy to get stuck. But just like, you know, when all the alien encounters that happen here, but where do they come from? You know, where they come from. So it was fun. It was a fun kind of thought exercise just to expand my mind a little bit and think about that sort of stuff. And where I landed was the center of the Milky Way galaxy, which we are a part of, Greg. I don't care what you say. And that's 26,000 light years away. And a lot of research on this, I just felt like such a stoner because I just kept having to go back to basic concepts like a light year. And in order to think about light years, I just had to be like, what is light?
Dude.
You know, to understand these things, there's like basic points of understanding, which I had very few of, you know, come to find out.
Is it a particle? Is it a wave?
Yeah, there's just a lot of things that we like take for granted, like light year for sure. Yeah, light years anyways.
Yeah. Okay. Hi.
Yeah.
I'm Michelle.
Are you about to ask what is a light year?
I'm Michelle.
Yeah.
Bobby, you've been talking for 10 seconds.
Yeah.
And already I'm like drooling. I don't know what's happening. What is light? Where is space? Is the Milky Way where we are? And the world's flat? What? Like, what just happened? And I feel attacked.
According to my calculations, the world is not flat.
Okay.
Let's start
fine.
there
We
for
got-
for the sake of this podcast. But
Check.
I appreciate those questions. These are basic things that again we just like take for granted. When you get into space, it's like so easy to get out of the realm of things that our minds can comprehend very quickly.
Yeah,
You know?
I'm already there. I can't comprehend Bobby, please tell me, what is light?
Light is electromagnetic radiation.
It doesn't really explain it.
I'm getting there. You got to give me a chance.
Okay,
you got to
okay,
give me a chance. Light is electromagnetic radiation. And so there's many elements of that. It's radio waves, infrared, visible light, ultraviolet light, X-rays. Hold on.
I know, I'm freaking out. I got to breathe.
Yeah, let me explain.
Okay.
So there's all these things. So we have evolved just to see a very like small spectrum of visible light. So that's like the light that we see, this rainbow spectrum. But light, essentially, for the purposes of talking about space in this context, is electromagnetic radiation. So it's radio waves coming across space, but not visible light as we think about it. And so the speed a light year is the distance that light, these electromagnetic waves, the distance they travel over 1 year. And which is just to back up a quick second, like all these elements of light come into play when talking about space, like the speed of light as it pertains to space-time. Light years is a relative measurement of time and distance. And we've just evolved to see that narrow sliver. But there are so many, and we're gonna really focus on black holes today. And so black holes do not emit light, but the things around them do. So light is kind of coming into play in many different ways that we're talking today. A light year, the distance light travels in 1 year, is 5.88 trillion miles. So just under 6 trillion miles. And just to keep it loose, what we just rounded off there was 120 billion miles. And so this is why we use light years, because it's like, what the fuck even is that?
Yeah.
What you just said. And like the center of the Milky Way, we said it's 26,000 light years away. That's 153 quadrillion miles.
I can't even, my brain can't even hear your words.
And that's just our galaxy.
I know. I have a really dumb question really fast.
Yeah.
If we're in the Milky Way,
Yeah.
how come I can see
We're going to
it?
get to that at the very end of the
Okay,
podcast.
six.
Yeah,
Okay.
I'm going to tell you about that. So,
Okay.
so this is why we use light years to measure this stuff, because our brains cannot understand 153 quadrillion, but we can comprehend 26,000.
Yeah. Or
Like, that's
one
a number
light year.
that we can
Okay.
comprehend is 26,000. So light years, compress this to something that we can wrap our brains around.
It's like any like unit of measurement. Like if we're going to say like 1 mile, It's like, well, what is that word mile? Like, and it's like a certain amount of feet. Well, what is a foot?
Right.
It's a certain amount of inches, like
Right.
or centimeters. Or,
If you told me, one football field, I'm like, okay, I can understand that. But if you told me, that's 8 trillion centimeters, I'm like, what now?
Yeah. And so, it's just this like real like shorthand that our brain does, like that light year is a specific distance, which you are completely unable to comprehend.
Got it.
So we're just going to for the sake of conversation, we're going to talk about it in this way. And I find black holes really interesting because I think another thing that our brains can't wrap around is like the infinite limitlessness of space, of just the endlessness of the universe. But I think a lot of the elements of the endlessness of the universe, those mysteries also manifest in black holes. And black holes are like a thing that we can see and think about and kind of conceptualize. So I think that's where a lot of the human interest in black holes, because it's a lot of the same, contemplating a lot of the same things of the limitlessness and the endlessness of the universe, but in a way that we can like pretend to understand.
Yeah, I'm already like, I've got so many questions, but also
I've got answers for 2 to 3 of them.
Okay, great. I'm going to hit you with a question, but first I have a statement, which is that I have not smoked weed in like 18 years.
Yeah.
I feel so stoned right now. I'm already like, whoa, dude, wait. So like light.
This was my whole research process, was just feeling so stoned.
Yeah, I feel stoned.
What is space-time?
Dude.
All of these things, yeah.
I can now, all right, so like the way I still don't understand what a light year is really, but I do understand that my brain can't comprehend it. So like fucking let it go, it's 1.
Yeah.
It's fine. But like... Who the fuck made up a light year? And how the fuck do we know how far that actually is and what even is light?
Let me throw this at you, which will help you understand it a little bit more and less simultaneously.
Sure.
That because the center of the Milky Way is 26,000 light years away, that when we are, like, that's a measurement.
Yeah, but
it's a distance. Hold on, bear with me. So when we are looking at the Milky Way, we're seeing it as it was 26,000 years ago.
Isn't that nuts?
Yeah. And that's before recorded history, before agriculture, before civilization. That's what we're seeing. And so the light is simultaneously telling us how far, but also
how long
we are seeing, which is a crazy concept. This is like the stoner thing, is like, when am I looking at?
Yeah.
But it's true. When you're looking at space, that is a part of the equation, is when am I looking at, is also like where, how far, but also when.
Dude, science is so trippy.
It's essentially how like they can predict that stars will be collapsing soon.
Right.
They know how long a life cycle of a star is at this point, and like they can essentially see it starting like its death spirals essentially. And it's just like, oh, that's what would have happened like X amount of millions of years ago. It already happened like a million years ago, but
they can predict it because it's actually in the past.
Essentially, yeah. And like
we're looking at stars that collapsed a million years ago.
And that information, it's just now coming and now hitting Earth.
Right.
As electromagnetic waves.
Like AKA
traveling.
light.
Yeah.
Right.
Yeah.
Bro. You guys.
So at the center of the Milky Way is a black hole called Sagittarius A star.
What up, girl? I don't know why it's
what
a girl.
Up, Sag A star?
Yeah. What up?
That was a weird noise I just made.
So Sagittarius A star is a supermassive black hole, and it's, again, at the center of the Milky Way. Getting into black holes is so interesting because you get into a world of theoretical physics. So a lot of everything that is said is theoretical.
Right.
A lot of it is backed up by mathematics, but still unproven and theoretical. So there's like these different kind of like stages. There's like, it's all unknown. We don't know anything. Like, these are all theoretical models. Like none of it's like actually factually known, but a lot of it fits these models. But then there's things that doesn't even fit the models. They're like the smartest minds in the world and the authorities on these things. They're like, we don't know. You know, they have no idea.
Perfect. Great.
So
love it.
With a black hole, gravity isn't pulling force, it's the curvature of space-time. So if you think about space as like a stretched rubber sheet, you put like a bowling ball on it and there's a dip. Like goes down. So that dip is what's pulling. And then if you like drop a marble on that sheet, it's going to like circle and get pulled into that. So that's what's going on in space with gravity. That's what's going on on Earth. If you picture it, against the rubber sheet of space-time pulling, that's where our gravitational pull comes from. So it's like this rubber sheet, but is like everywhere in all directions and being pulled everywhere in all directions.
You're freaking me out, man.
Yeah. I'm freaking myself out.
You're freaking me out really hard right now.
I've been on a journey.
And in terms of like the theoretical side of it too, I think it was Einstein that came up with the theory of black holes, or like he theorized it. Like in his mathematics, he came to this conclusion that there has to be something that's doing this.
Yeah.
So he essentially came up with I don't think he came up with the term black hole, but he came up with the concept of that being present. Back then, I think he was even like, oh, that's crazy. Like, it's just, how about your equations are wrong?
Right.
And like, that doesn't exist.
Yeah.
And I think a lot of people saw it that way. And then eventually was proven right. And like, it's just like, so mathematics does take us so far into like, from theory to fact. There's so many of those types of equations that still exist today that we have no way of actually making known. Like,
right. I feel like when we say, oh, his equations turned it into fact and we know this now, until it's disproven and new math says something else.
Right.
That happens all the time in physics.
And that's science. Like that's the purpose of it. There is no like one thing, and like the whole idea of science is that it changes.
Right.
That's the whole point.
And so much of investigating physics and making this stuff happen is like, because it's space and it's so abstract, you kind of just have to like pick a starting point and then try a bunch of stuff.
Right.
And sometimes it works. And it seems like a lot of physics is like it mostly works. And I couldn't help but think of like a number puzzle, or a crossword puzzle, or like a Sudoku or something like that. And oftentimes when you get close to getting it right, it's like sometimes at the end when you get close to getting it right, it's like, oh, okay, like, no, I needed the 8 here and the 9 here. You just have to transpose those. But sometimes every number is wrong.
Yeah.
Sometimes you're so close to finishing it. And then you realize that it doesn't work at all and everything is wrong. And so that stuff happens all the time in physics. Is like, this model is so close to working. It's so close to explaining this thing. But then it's like, no, everything is wrong.
Fuck, dude.
All of it's wrong.
Oh my God. Could you imagine working your whole life on something and then the whole puzzle's wrong? No.
That's what all these people, they do it to each other too.
Oh,
they're like disproving each other all the time.
Yeah. Oh, that's fun and awful.
I just want to also I just thought this was so interesting in like the different types of people there are. There's a guy named Carl Schwarzschild who's a big figure in early black hole stuff based on work that Einstein did. And he provided the first exact solution of like Einstein's equations for general relativity. But he did so while in the trenches on the Russian front in World War I.
Oh, yeah. Like from the battlefield?
Yeah.
Fuck,
he's
dude.
there. He had
He has nothing else to do.
He had like a journal article that Einstein had written.
Yeah.
And then he's just like in the trench just thinking.
Doing math.
Just thinking with his awesome brain and just like making sense of this stuff. And the stuff that he made sense of in the trenches is still like foundational work in black holes. Like he was right.
Yeah.
Crazy.
Man.
I just like think about like myself and like how dumb I am and how I spend my stupid time.
Yeah.
And then it's just like, there's guys like this. It's just like doing these things simultaneously.
Yeah.
It's crazy.
Yeah.
It's like, come over here, big boy. Shooting people. Then he's like immediately like, oh, black holes.
Yeah, that's math.
Yeah, it's
I don't even know how to describe math.
I'm just thinking of the meme.
Dumb dummy. I can't even like give a like reference.
There's just like the meme of like anyone just thinking of something. It's all the equations bouncing around in their heads.
Yeah, and his that's what his actually look like. You know what mine look like? Boobs and Homer Simpson.
Yeah.
You know?
This is something that like I and maybe this is a really stupid thing to say. And like if you're a physicist and you're listening to this, like first off,
Sorry.
I'm sorry about I'm sorry about your fall from grace. Like get it together, stop drinking, call your mom, like get it together. Why are you here?
Yeah.
But also like tell me if I'm completely off base with this, but like to take a step back and think about it really abstractly, how did math become the language of space?
Right.
Like it is the language of how we work to understand space, but like it's fucking space, dude. Like to like impose this grid theory idea of mathematics on these things is interesting to me. It is a good language to talk about, to discuss it, but it is the authority, and I'm not sure why.
Well, math is the authority of everything. Math is actually everything.
According to them.
Well, I think it's just a matter
Fibonacci.
of like, there's only like a way to describe,
Right.
Not even describe, but like it would just to make sense of everything.
I guess
and
I
like when we can use it to make sense of everything here, we can only use that now to like ascribe it to the like higher planes as well.
And so it's not so much that I take issue with math being the language of space. I was just curious as to like why it's the only language of space, you know, and I'm not proposing like I have the right answer
Right.
or a good
Yeah.
answer.
Yeah.
But and I know I find physics is so fascinating, so interesting to me because it is this place where this like wild abstract thought like comes together with mathematics.
Yeah.
And like, that's crazy.
Yeah.
And I do appreciate that there are people, and maybe that's where I'm going, is to just that, like, I almost feel like it's more the territory of wild abstract thought than mathematics.
Right,
You
right.
know, but good on math for trying to make sense of it, even though it rarely works.
Yeah. Got it. Yeah.
So,
Yeah.
Yeah. And so the black holes form in different ways, but many of them, most of the black holes are called stellar black holes. And a lot of those are created when stars die. And what's going on with a star is there's this energy inside nuclear fusion and gravity outside, and they're kind of like the fusion is pushing outward, the gravity is pushing inward, and they maintain this balance for this time. But as the fusion, it is finite and it starts to wane. The gravity keeps pushing in, pushing. The energy is getting smaller, so the gravity's pushing in until the fusion runs out, but the gravity continues to push in, and so consequently condensing the volume of the star, but it doesn't lose density. So it's just like getting it to be a smaller, denser thing. And
It's like taking a coal and pressing it to be a diamond sort of thing.
exactly.
Good one.
So as this
Yeah,
star,
my fucking stupid brain can understand that. Fuck yeah, dude.
diamonds,
Yeah, got it.
as the star like collapses, it's imploding. And so this is happening. And so now take it back to the rubber sheet. You know, you have this thing that is getting denser, and what's going on with black holes is this density is infinitely growing. And so imagine something that's density is growing, and as it's dipping into this sheet, the dip that it creates becomes so steep that nothing can come back out. And that's a black hole.
Okay.
The end. No.
I'm thinking, okay, you guys.
Yeah.
Check it out.
Yeah.
I have a mouse problem. Right. So I created something called the murder bucket. Right. And these poor little guys, I trick them to go in the bucket, and it's so steep, like your black hole, that they can't get out.
Yeah.
And so now
Get in the bucket.
your little diamond star is a little dead mouse in a black hole.
That's right.
Okay.
Yep.
Black
Yep.
hole bucket.
And
Got
this
it.
is, I mean, like, this is a part of science that I really enjoy. And that was a part of the thing that I enjoyed about researching this is like, how do I understand this? Like,
Yeah, I need
how do
you
I
to
make sense of this to myself? And
Well,
that
I think
was a
of
big
like
part of the
gravity too. I
process.
think like all mass has gravity, or I could be dumb, but I'm pretty sure all mass has gravity.
I think because as it's moving through space time and like pushing on the sheet, if there is mass, there's going to be a pull. Yes.
And this is my own thoughts on it. I'm sure it could be discredited or whatever, but like I always think about like when I'm walking down the street and people always tend to bump into me. And I'm curious if that's like a
Your
super
own pull.
my own like super low level gravity type of thing. Like if us walking through a crowded street, obviously if it's a crowded street, people are going to bump into you. But like,
Right.
I don't know what it is about me being out in public. It doesn't happen to anyone else.
Sounds like you're looking to fight.
It sounds like the problem is you. I think you're bumping into people.
No, well, it's like I go out of my way to try to not
Right.
bump into people, but like I'll be
Interesting.
like stationary sometimes, and people will bump into me.
I think something that's come across, you guys know me a little bit, you know, the people listening are starting to get to know me. I am an idiot. I'm a big dumb dummy. For a long time, like a stretch of years, people would often ask me for directions. People would come up to me every single day. Somebody would ask me for directions. What in the actual fuck about me makes me look like I know where I'm going at all, or that I could help you get to where you're going?
It's that you may look baby nice and approachable.
People would
I
ask
do
me
now.
as well.
I do now because I look like a mom. I mean, I'm not a mom, but like I'm a brunette now. That makes me feel. Sometimes I wear a grown-up coat, you know, so people don't know that I'm not a grown-up. But this time period, I was not as approachable looking as I am now.
Yeah, but I mean, maybe they were picking up on some energy.
Yeah. Well, I think that's what Greg is saying. Like, I've got a directional gravity You know, that people are like, oh, she's the lady, you know, and they're like, oh, bump into this fucking guy, you know, because Craig's gravity is like, hit me.
Yeah. And I mean, all of these objects in space have different gravities and different things apply to them. And they
All I'm trying to say is
differently.
I'm dense. I'm not fat.
Right. You've got some mass.
That's right.
You're creating some gravity.
I've got some volume.
I am 6'2", 200 pounds. So
Yeah. I do like that my thing is like how to get people to get away from me. They're like, hey, where do I go? I'm like, that way, so far that way. Get away from me, go that way.
I always tell people to look at the phone because they usually have it in their hand. You have the thing to figure this out.
Fair.
But yeah,
Are we back?
yeah. Let's do a little sidetrack.
So the collapsing star accounts for a lot of the majority of black holes are stellar black holes. The collapsing star accounts for those things, but there are supermassive black holes.
Ooh.
And there's also intermediate black holes, but whatever. Supermassive black holes, we're not quite sure how they're formed. Potentially early universe gas clouds collapsing.
Father problems.
Also, yeah, that's right. Smaller black holes merging over time, which is very interesting that like there's this pull and space is doing its thing, but black holes can
Merge
close
together.
to each other and start to pull and spin around each other. And there's actually a pretty awesome recording of these radio waves that came across space over, I forget how much time, but it's a lot. They have a sound. They have a recording of two black holes merging. And it's like, there's like nothing. And then it's like, boop, 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 boop. And like, that's these black holes merging together.
Oh my God. Can we play that on the thing? Are the rights open?
Yeah, it's a great idea.
Yeah. The Conspiracy Journal is going to buy the rights to that sound.
Yeah.
Okay, cool.
So at the center of our Milky Way is Sagittarius A star, a supermassive black hole.
Yeah.
So we're going to talk about that a little bit, it's easy to kind of focus on one black hole as opposed to all the black holes, of which there are many, both stellar, intermediate, and supermassive.
Okay.
It's in the direction of the constellation Sagittarius, which is where it gets its name. It was first detected as a radio signal by a man named Carl Jansky in the 1930s. He's one of the fathers of radio astronomy. So he's just like got stuff pointed at space, just like listening, you know? And so he's catching these waves in like a high concentration of waves in this area. And I'm never cease to be amazed of how much people in like quote unquote olden times, you know, be it the 1930s or like Galileo could like figure out about space. Again, to my dumb self. I'm just like, I don't know. You know, but like the amount of knowledge they were able to gain without modern technology is pretty staggering. So big ups to Carl Jansky and his headphones.
Do you mind if I take a short little thing? Because I'm just thinking about like the sound of like merging black holes and like the idea of what but like we can ascribe that sound to literally anything. So I wonder if we took like the human language and like put words to specific frequencies, so when we heard it, it was like the universe talking to us. So like we wouldn't necessarily just need like the weird radio sounds that we would get. We would just get words, and it would just be like essentially be talking to us.
If there's like that would be
now I'm high.
Now I'm so high right now.
There'd be like different codes for different languages, but you could apply them to the radio waves and like these things. Yeah. Man, I really love this stuff. You know, all these things. Contact Jodie Foster, like on board. Really enjoy all this stuff. Yeah, it's so fascinating to learn about. So there's this high concentration of radio waves that Carl picks up in the 30s. In 1974, a couple of astronomers, Bruce Ballack and Robert Brown, they're like, okay, like this is a powerful radio source, you know? So they're like narrowing in a little bit more on like what it is. And this is coming from this specific point. It's extremely dense. It's powerful and invisible. Also, like we can't see what is there. And so it was speculated for a long time. It wasn't like a surprise, like, holy shit, it's a black hole. It's like, it's probably a black hole. Which is how, like, there's not a lot of, like, active mind-blowing. Like, a lot of this stuff happens with theory. Somebody throws a theory out many years before, and they're like, maybe it's this. And then it's later proven. And so that's what happened with Sagittarius A. And in, like, 2002, I believe, a couple of astronomers, Reinhard Genzel and Andrea Ghez, started to look at it more closely, and they started to track stars near the center of the galaxy around this area. And they were tracking a star called S2, and it's whipping around the center of the galaxy every 16 years at about 2.5 times the speed of light. And so here's the kicker, is that according to Einstein's theory of special relativity that like so much of our knowledge is based on, nothing with mass can reach or exceed the speed of light.
Right.
And
Because it will explode
But they're
something.
seeing that nothing can reach the speed of light, but they're seeing this thing travel at 2 times the speed of light. Right. So as something approaches light speed, its relativistic mass increases, time slows down, legs contract, and the energy required to accelerate this thing approaches infinity. And so to reach the speed of light, you'd need infinite energy. And to exceed the speed of light, you broke physics.
Right.
So that's everything about black holes is like physics is broken. That's kind of the base thing. So they're seeing this thing happen that destroys all the laws of what we know and how we understand space. So, and they're like, that's weird.
Why don't we just build a warp drive? And we need to create a static warp shell around our ship, and then we can travel faster than the speed of light.
Yeah, that's for the back end of the show.
That's Star Trek.
Yeah, but also like you're just gonna explode, bro.
And so this is
you're just gonna blow yourself up.
Black holes is just like physics are just breaking over and over and everywhere. And so to keep a star moving that fast, you'd need like 4 million suns packed into a region smaller than our solar system. And there's no stable cluster of stars that could do that. And so the only explanation left is a supermassive black hole. And that's how a lot of this study goes, is like you're just eliminating all possibilities until there's only one possibility left. And what happens next is you win the Nobel Prize. Congratulations.
Yeah. Oh, thank you. Thank you. Shake my hand.
for
Thank
them.
you.
Yeah.
I did it. You're welcome. Everybody, guess what? I can't explain it. So therefore it is a super massive black hole. You're welcome.
So they, have figured this out. And in May 2022, a project called the Event Horizon Telescope was able to photograph Sagittarius A star.
Nuh-uh.
Yeah. It's all of these different telescopes from around the world. And I really loved this analogy. There's a great documentary about it. And I really loved this analogy that like essentially what's happening with these telescopes is like if you break a mirror, each one of these telescopes is essentially a shard of that mirror. And then once you get all the data, then you put it back together.
Okay.
And so that's kind of what's going on as we form this picture. And so there's observatories in the United States, Mexico, Chile, Spain, France, Greenland, the South Pole, and Antarctica. So all of these telescopes are taking images of this at the same time. And you can't see a black hole, but around it, there's like superheated plasma swirling.
Right.
A lot of energy, in that. So that's what we're seeing. And I'm going to do the thing where we're just making really, really great radio is where I use pictures.
You're going to show me a picture? Yeah.
I'm going to show you pictures. This is...
Oh, the Eye of Sauron.
This is Sagittarius A star, also known as the Eye of Sauron.
Yeah.
Yep. And so...
It's beautiful.
When you look at black holes, this is kind of the structure. Is there's like the ergosphere, which is the outside. So when you're inside the ergosphere, you're affected by like the gravitational pull of this black hole, but you're still safe.
Right.
Let's say it
you're
that
still
way.
outside
You're
of
still safe.
it.
You're still outside. And then part of the structure of it is the accretion disk is a big part of the black hole. So that's the thing that's going around. And this is such a fascinating image. Again, sorry to the listener. Check this out. You can look up these images. This comes from NASA.
I think Interstellar, the movie, was the first film to get black holes right. So when you're thinking about the image that we're looking at right now, it's that black hole image from Interstellar, if you've seen that movie.
It's quite incredible. So what you're seeing is essentially a disk. If you picture, like we all know what Saturn looks like, so a black hole, we often because it's called a hole, we think of it as flat. But black holes are spherical, and active black holes that are spinning. Again, we're getting into theory here. There is like theory that the possibility exists for a non-spinning black hole, but to our understanding are all the ones that we've observed are spinning black holes. And so you picture a sphere that's lightly squished, just a little bit. And so it does have a pole. And so on the axis, on the middle, if you picture the rings of Saturn, there's just like a flat disk around that. So black holes have an accretion disk like that. And so as it's collecting mass and energy that comes towards it, that's a way for it to keep that mass and energy stable. Is as it spins, it forms into this disk. But black holes are so mind-blowing that even though it's a disk around the center, this is how, if you're looking at it at a certain angle, it will appear this way, where like the disk is bent and you're seeing the sides and the top and the bottom of it all at the same time.
I'm so high right now. Dude.
And that's like everything about black holes is like everything everywhere all at once.
Oh my God.
You know, God, it's so interesting. And so back to like the image of Sagittarius A star, you can kind of see the accretion disk is here. And then you can see on the end, there's like jets that come out of the poles that are just like blasting energy. So it's just like, and it's so insane that you can see this in the actual image of the black hole that they took. And so yeah, you're seeing all of the mass and energy and accretion disk around the black hole, which is awesome.
Dude.
Yeah.
It's also weird to think about it. I could be wrong in this assumption, but all of that, like we call it plasma, and I'm sure part of it is, but if you think about how stars look in the sky and imagine that thing eating like a million stars all at once. So it's just all individual things, but they're sped up so fast that they're leaving light streaks.
Right.
So it is an individual thing, but it has this giant streak behind it. Just because it is moving that fast, and like the way that light travels to us, it appears as a streak, but the closer you would get to it is just like that solid object still moving around and like rotating this thing.
Dude, my brain can't even handle this.
It's so fascinating.
I could be 100. I'm just talking out of my ass.
No, you're absolutely right. And we'll get into a little bit more of that, like kind of once we get inside the black hole. So we're not inside yet. We're still looking at it from Earth at this point. It's all of course. It's
wet.
everything.
It's dry.
It's everything.
It's everything. It's hot. It's cold.
Absolutely.
It's burning. It's burning cold.
Yeah. Everything, everywhere, all at once, all the time. And so as they're imaging, this was just another fascinating part for me to learn about. That's like, how are we taking this picture? Where does this photograph comes from? And so all these telescopes are measuring radio waves that are coming from this. They're measuring the amplitude, like the strength of the waves, the phase, the exact position of the wave cycle, and its arrival time using atomic clocks. So all of these data points are coming to these different telescopes, and then they're putting all this data into a supercomputer and combining all this information, and that's how they're able to come up with these images.
Okay.
So yeah, there you go.
It's good to know that we're feeding all this information to AI as well.
Again, we're using theorems and physics to fill in the blanks and the constraints to make sense of all this, because it's real far away. I don't know if we talked about that. It's 26,000 light years ago.
Yeah, it's really
far, far away.
Yeah, it's really far ago.
Yeah, 26,000 light years ago and away at the same time. And the image matched Einstein's predictions almost perfectly. That he's like, this is what's going to be going on. This is what it's going to look like.
Guy was so smart. His hair was so cool.
Now, is there any like bias there? Like they're trying to match the information that they're receiving to match Einstein's thing. So like, is there a bias to try to prove his stuff right? So like, they're not like manipulating anything. Like the information's still the information, but they're now just going to use it to like, oh, well, if we construct it to look like what he was expecting.
Not necessarily. It's kind of cool in this documentary. It's the Dolman Telescope Project is, kind of what they're focusing on. And they have an element in there where they took all these data sets from all these different telescopes, and they had very purposefully, they sequestered themselves and did not communicate with each other. And they had each of these teams from each of these different telescopes image the data, and then they compared those images. And they're not identical. They're taken from different positions, but they're like almost the same.
Okay.
And so they did take a lot of care to be like, are we manipulating this data? And very specifically, like, did not talk to each other. They were like, don't even talk to each other about what you think it's going to be or what, because the human desire to push the data towards what you want it to be to make sense of that thing. They're always very aware of that, and we're very careful to stay away from that. Yeah, for sure.
Yeah, smart guys.
They did a great job.
Turns out.
Great job,
Still
everybody.
Smart.
Yep.
Did a good job.
And to the listener, so sorry. What we're looking at and talking about is essentially like a glowing ring of fire.
Yeah.
With the deep black void in the center is what a black hole looks like.
Is there like
images that we're looking at?
Is there a way for them to Google?
Yeah, absolutely. You can Google like black hole. NASA has great images on their website. A website that I love called space.com.
Yeah.
Also has a lot of good stuff on it. And then also, if you're looking at the specific image that we're looking at, a Sagittarius A star is the name of this black hole. And so it's very easy to find these images. And you can see the different images that the different teams came up with using their imaging and their data points. Sagittarius A star occasionally flares. And in 2015, there was like a flare 400 times brighter than normal. And again, this happened 26,000 years ago. So,
right.
And also they're just like, wow.
Cool.
Like, no, we don't know.
Yeah.
We don't know what happened.
Yeah.
In 2019, it brightened 75 times above its usual levels. And so it's kind of fun. And I really appreciate physicists for their like willingness to be wrong.
Yeah.
You know,
Or not
in
know.
this stuff. And in 2014, there's a gas cloud called G2, and it's like kind of pass over the black hole. And they're like, this is going to be crazy.
Yeah.
Like, we've never seen anything like this.
Yeah.
And nothing happened.
Bummer.
So it's just like we think we know how a black hole works, how we understand it, you know. And I think a lot of the normal, like common idea of black holes is just like that they're this insane vacuum.
Yeah,
and,
they're
like
sucking
anything that
everything
gets
in.
near
Yeah.
is just like sucked in. And it's like once you're in there, you're not getting out. But it's not like, so it's not in such a violent way
Right.
as that description. So there's an element that's like, yeah, once you're in, you're fucked. But it's not so active as we might think in how we understand our world. And Sagittarius A star has been in fact described as sleepy. You know?
That's cute.
So, yeah, just a sleepy little black hole.
Yeah. She's not going to suck you in, but if you go jump in there, you're not getting out.
Yeah.
It'd be a shame if we had any like physicists on Earth trying to create them in labs, like at big places in Europe, like CERN. I hope they don't do that.
Or
that would be
Dolce.
bad. Yeah.
Yeah.
That would be bad.
And so let's go inside.
Okay. Yeah. Fuck yeah.
I
Let's
thought
go.
we were in.
Let's get in here.
No, I mean,
we've been circling around the
okay.
edge.
All right. So, yuck, ew, gross, puke. Question.
Yeah.
How do we know what it's like in there if nothing could ever come out?
Theoretical physics.
Okay. Give me the math, baby.
Yep. So you're drifting towards Sagittarius A star, and you start to see, as Greg talked about, light from far away stars like starts to bend and stretch into arcs. You know, so the way
Trippy.
that we see and interpret the world starts to twist and bend and manipulate. Time slows down. And so like a year for you is decades outside of this zone. At this point, we're in the ergosphere. We're drifting closer and closer towards the center of the black hole. And yet, as I did this research, I was more and more impressed with the movie.
Interstellar?
With the movie Interstellar.
for
like
sure.
you know, I know it's like kind of a joke that's like, oh, dudes just love Interstellar.
Yeah.
But like, I was like, damn, they did a good job.
Yeah.
You know?
Yeah. I'm thinking
also,
about it the whole time.
Go fuck yourself. Watch that shit in IMAX. It's incredible.
Dude.
It's the only way to watch it, I think.
Yeah.
Dude, did you go last year?
Absolutely.
Oh man,
Absolutely.
We probably went to the same. So there's a Lincoln Center in New York City has the only true IMAX, and
In New York City.
yeah,
It
in
is-
New York City. Sorry.
But it is the biggest IMAX screen in the country, I believe, tied with somewhere else, but who cares
Yeah.
about them?
Yeah, exactly. And so last year was the anniversary, 25 years or whatever it's been. And I have never in my life seen so many nerds. I mean, I bought tickets. I had so much fun.
Same.
It was incredible.
Yeah.
I highly recommend it. If Interstellar comes back to IMAX again, everybody go see it. It's really good.
Yeah. It just like, I think I'll probably, next time I watch it, I'll probably enjoy it so much more because now I like actually
You have a little bit
understand
of
this
an
stuff.
understanding.
Yeah,
And
I'm
like,
going to watch it tonight.
and like him when he's in that like weird place and he's like looking out
Yeah.
and like specifics of like him not aging in this way, you know, and the way that time passes. And now I just understand a little bit more spatially, like where he's physically positioned
Right,
and
yeah.
why they're aging so differently.
Yeah, totally. And even just like small things like why is
By
everything
he,
so
I mean
streaky?
Matthew McConaughey.
Of course.
Yeah.
Duh.
Yeah. Everything is
why
so
is everything
streaky.
so streaky? And like now I get it.
That's reality.
Yeah? Fuck yeah.
Yep,
Okay.
absolutely. And so you're having this experience, but if somebody was like watching you float towards the black hole, it's like also first like dickhead. You just let
Yeah.
them go, you
Yeah.
know? But you will appear to freeze.
Oh,
Like at
see?
the edge of the black hole, and the light that you emit as a human being becomes redder and dimmer simultaneously.
Weird.
Yeah. And so as you're drifting, all of these things are like kind of happening simultaneously and like in different places at the same time. And so you're drifting, you will cross the event horizon. And
What is the event horizon?
That's
thank you, Michelle. I'm
point
I'm
of no
so glad
return.
you asked. That's the event horizon is the point of no return
Okay.
because you were like definitely in control up to this point.
Right.
So
Totally.
you're doing
I'm
great.
a red
And so
being in space, but I had a chance.
It's not like a specific wall or anything recognizable. It's immeasurable into like where it is as you're drifting into this black hole. But once you're past it,
You'll know.
once you're past it, you can't go
Well,
back.
think of it like this: if there was enough gravity pulling you into a thing, you would have to have more energy to get out.
Right.
So there, at a certain point, you will have not enough
Energy to come back. Yeah.
leave.
Apparently, I need to rewatch that movie too, huh, guys?
What's that?
The
Lawrence
Event
Fishburne's
Horizon.
Event
Yeah.
Horizon,
Yeah.
that seminal 1996 film.
Yeah.
I don't know if it was 96.
That all
but,
told
yeah.
us like how wormholes work, and you have to bend a piece of paper.
Maybe that'll
with a
be
pencil.
Yes, exactly.
one of our special conspiracy journal movie pods. We can check out Event
Hell yeah.
Horizon.
Yeah. Okay. Cool.
And
You want to see hell, kids?
once you pass the event horizon, this is the area where like no light escapes, where the black hole gets black. So you're a being of light. Everyone, we're all beings of light.
Absolutely.
But as you go into the black hole, your light dims and goes out and never comes out again.
Fuck, dude.
And also in a supermassive black hole like Sagittarius A star, the event horizon is so large that you're not going to feel like a line. You're not going to be like, oh, shit,
Oh,
I
yeah.
passed the event horizon.
Right.
It's slowly happening. Maybe you feel good. I don't know.
I hope.
But like everything is
Yeah.
getting pulled inward. And then what happens at some point is instant spaghettification.
Shut the fuck up. That's not a word.
That's what it calls. Yeah.
No.
They love everything that you read or listen to about black holes. They love spaghettification. Everybody talks about spaghettification.
Like if you went like toes first, you would start to see essentially your body be ripped apart and like spaghettified.
But your whole being will become like one long infinite stream of plasma, instantaneously, forever and always,
guys.
endlessly.
You know how I talk about the line where I'm like, I believe everything, I believe everything, I believe
That was
everything,
it.
and then I
Is-
hit the line.
is spaghettification.
We
the
sounded
line?
so smart until we were like, and then spaghettification. That's kind of, it's so weird to listen and research all this stuff, and all of it is like theoretical physics, Einstein formulas, spaghettification.
Smart. Shut the fuck up. Oh no. Okay.
And
sure.
I sometimes I crack myself up. In my notes, I wrote, "You done."
You're done. You're spaghetti.
That's the point I think where you like cease to be.
That's when you
anymore.
scream, "Mamma mia!"
Yeah,
Is that what Guns N' Roses, the spaghetti incident, was actually about?
of course they love theoretical physics.
Yes and no.
Yeah, true.
Famed physicist Axl Rose.
That's right. That's where I learned this.
Yeah. He's a
Might
he's a
as
black
well
hole
be.
enthusiast. Yeah, absolutely. He understands it as well as anybody else.
Truly.
You know, and it's like, but what of the spaghetti? No one knows.
That's
Right.
a,
You know-
that's a T-shirt. That's a good quote.
Fuck
Yeah.
yeah.
What
dude.
of the spaghetti?
But
Nobody
what of
knows.
the spaghetti?
And so you're just like, we're talking about this kind of in ways that like seem like we can understand,
Right.
but you also have to remember that the like
This is like coal into diamond type
Yeah,
of thing.
and
It's just
the-
like
the
we're just using
density
words to make it.
as we're like getting into the sheet, the drop becomes like infinitely precipitous, you know? But it's like, does that mean that like circles? But like,
Yeah.
no, that's not what it means.
No.
But it like becomes
It's everything
steeper
all the time, all at once.
Exactly.
Yeah.
Exactly. So like
It's
with
down,
our
it's
like
up.
degrees of understanding, it's like you can only get so steep and that's down,
Right.
but it's like gets steeper than that. And so we're in there, and this is where the singularity comes in. And I just want to like read some words so that people have like a correct understanding of what this means. And in a black hole, the singularity is the point at the very center where gravity compresses matter to an extreme limit. All the black hole's mass collapses into an infinitely small point with infinite density and zero volume, where space-time curvature becomes infinite and the known laws of physics break down. Most physicists believe infinite just signals that our current theories are incomplete, and a theory of quantum gravity is what's needed to truly describe what happens there. So again, it's like such a crazy thing that we cannot fathom or conceptualize, which is why I wanted to like give it to you in a concise way.
It's almost like a pinprick through the universe. Like if you use like a fabric sheet or even the rubber sheet idea, and you had a pin and you were pushing on it, And like that pin then created a hole, but it's also like a gravity well. There's,
What's on the other side of the hole?
What's on the other side of the
exactly,
hole, bro?
exactly. That's
Yeah.
the singularity.
That's what we
fuck
don't
you
know.
guys. Fuck you guys, dude.
Yeah.
Fuck everybody. Fuck
The
this.
singularity is hidden. Everything
Yeah.
is hidden beyond the event horizon, so we cannot observe this.
It's probably another universe with a black hole in the same exact spot that's feeding into the other side.
It's the bookshelf from Interstellar or something.
That's right. That's
Fuck
right.
me, dude.
And so,
I
like,
can't handle this.
for a long time, they weren't sure, like, if black holes died. In
Oh,
kind
yeah.
of what
Good-
happened
great
to this
question.
time span, this
Yeah.
lifespan. There was also believed to be an informational paradox. It seems like something that physicists seems to really hold close to their hearts is that information cannot be destroyed. But it's like we're dealing with stuff where we don't understand the
Right.
laws of anything. So
Right.
I would push back on a little bit of that. It's
Yeah,
like,
yeah.
You don't
for,
know.
For sure.
You don't know that. But Stephen Hawking did come up with a theory of something called Hawking radiation. And so they were able to like essentially observe. For a long time, it thought that nothing came out of a black hole, but they were able to observe that this tiny quantum events are happening at the event horizon and small amounts of energy are escaping from the black holes, so this Hawking radiation. And so it's like kind of natural, I think, to theorize that maybe this, like, if you hold on to this information can't be destroyed, that maybe it has been
Right.
spaghettified, turned around unrecognizably and is emitting in this Hawking radiation. And then also consequently, as these tiny quantum events are happening in this Hawking radiation is coming out, there's an evaporation element, so that black holes will eventually evaporate, which also like is equally fascinating. You know that there's this entity that happens in inside of it. This is a singularity, and then that disappears.
It just disappears.
But it's
is
like
the answer.
It's interesting though, because like all of this is gauged on our own Earth perception of time.
Exactly.
Yeah.
Exactly.
So like a black hole could probably just be a blip in the universe. It's just like it is something that just like happens in a snap.
Right.
And it's just like this fucking odd. It's just it is that boop boop. And
Yeah.
like that's as long as it takes.
Yeah.
But our perception of it has it at like, oh well, this is just an infinite thing.
Yeah.
But it could just be
A
like
massive black hole.
and it's
Yeah.
done.
Wow.
Yep. Exactly.
Yeah. Because the time is so far.
And like all of this is so wild, and just like, you know who doesn't give a shit about any of it? The cold, indifferent Sagittarius A star, supermassive black hole in the center of our solar system, 20,000 light years away, 26,000 light years away, holding everything together.
She's just chilling.
Just doesn't, none of this matters.
Right.
Nothing matters.
No.
Right? Who? What?
What?
Who doesn't matter? Who says it doesn't matter?
black hole.
Sagittarius A star
Yeah.
doesn't care about any of this.
That's right.
Oh yeah, it just
You
is.
know, I feel like a lot of this is like God, you know?
Well, that was always the case.
God
is
is in
God,
the God is in the black hole, dude. I feel like Sagittarius A star is God, bro.
Well, I think as science progressed like through time, the term for God like kind of shifted, and it was just like the God of the edges, and it was just I don't know, therefore God,
Yeah.
and that was always like the explanation that a lot of like religious people ascribe to it.
Right.
But it's just like but as our understanding of the universe grows and grows and grows,
God gets smaller.
God gets smaller, but also our understanding of the universe gets bigger. And it's a weird fallback that they always go to of just like, well, you don't know, so therefore God. And it's just like, sure.
Sure, until science kills God again. Got it.
But there's always going to be things we don't understand. And that's like the fun of being alive.
Yeah, absolutely.
And like having
It's so fun. You guys go learn about black holes. It was really enjoyable.
Yeah.
Yeah. And it's this one thing, like I like researched this for this podcast. Absolutely. But like, there's so many like side quests when researching black holes, like what is light and what is space time.
Yeah.
we're
and
finding
all
that out a lot
And
with
it's
everything.
so fun. Yeah.
Dude.
And it's like, like this is one that I will go back to in my free time to be like, let me learn more about this.
Yeah.
There is a book. It has nothing to do with a conspiracy journal, though. But it's Brian Greene's The Elegant Universe. I would recommend checking that out. Like that's more quantum entanglement and quantum theory, but like it essentially relates back to black holes and like how we experience time and how everything's connected and things. It's cool.
All that stuff, like I didn't even mention string theory. You know, like that's like you could obviously spend a whole career and lifetime thinking and talking about string theory. But that's one of kind of the explanations of black holes in a really rudimentary way to the layperson if you're unfamiliar with string theory. It's just a theory that, not just, but a big part of it is that, we think that our world is constrained by these handful of dimensions that we have. But in fact, there are maybe many more dimensions outside of like length, width, height, depth, that there are all these other dimensions that are at work that are invisible to us. And
I mean, there's
at play.
Obviously there are, because we have so many instruments that like can like talk about radiation. Like we have instruments that can detect it. We can't see it.
Right.
There's infrared light. We can't see it. We can detect it. There are some animals that can see infrared and can detect it better than we can. So everything that we live through, we just assume like that's everything.
Right.
And it's just like, well, that's all our little monkey brains have
Exactly.
the capability of
Yeah.
understanding and
Yeah.
then taking in. Like just because like we can't see it or we don't know it's there doesn't mean it's not.
Right.
And the limitation of, well, if we can only conceptualize what we can only conceptualize,
Right.
and there's probably things at play. I would bet some money that there are things at play that we have no knowledge or
Right.
are unable to conceptualize completely because we have such a finite understanding of how things work.
There's something I was talking to a friend of mine many years ago, and we were talking about abstract things like this and like higher power, God, blah, 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 how it all works, how it's all connected and whatever. And just the idea of like our brain not being able to understand a lot of this stuff. And it dawned on her while she was trying to give her cat medicine one day. And if anyone has had an animal before, sometimes you got to like hold their mouth open. It's a struggle. They don't want you to put something disgusting in their mouth. So they're trying to avoid this. And it can be kind of a traumatic situation. And as the human, that you are trying to save this little animal's life by giving it the medication that it needs, but the animal does not understand that. They're trying to get out of here. They're like, why are you doing this to me? And so my friend was like, oh, whatever life is doing to me, like could be saving my life, but my cat brain can't understand it,
Yeah.
So when you guys are talking, I'm like, oh, fucking, this is some cat brain shit. I can't understand this.
Yeah.
Well, that goes back to the idea of like spirit guides and like the spirit world, like interacting with us and like guiding us along.
Yeah, for
and, like
sure.
people have that feeling that like, oh, this is beyond me. Something incredible and miraculous happened. And trying to explain that to someone that it didn't happen to,
Right.
you're not going to.
Yeah.
You're going to sound like a crazy person.
Right,
but
right.
for people that have this sense that there is more happening in this, like on this plane that we just can't see or physically interact with.
Right.
As again, going back to science, exploring those ideas, like the more time goes by, the more we're starting to realize that there probably is stuff around us that like is interacting with us,
Right,
and
which is
doing things with us and guiding us along.
the funny part about this is we're talking about these people who study this, that the scientists, the physicists, Einstein, these great minds, as the people who are discovering this. But at the same time, if you're talking about it, you're a lunatic. You
Yeah.
know what I mean? Geniuses have always been thought as lunatics until they were right.
In that vein, I did want to touch on a couple things.
Oh, yeah, hit me.
Including black holes as wormholes.
Yeah.
And this
yeah,
is
cool.
this is a lot of like how I landed on this topic in the first place. Like I said up top, like again, the constraints of the mind, when we think about aliens, we think about them on Earth. And it was like
Right.
where'd they come from, where'd they go, how'd they get here?
Yeah.
And a lot of people's like
Cotton Eye
argument
Joe.
against aliens is like exactly Cotton Eye Joe, thank you very much. A lot of people's idea or like the dismissal of aliens is like there's no way they could like travel this far or how'd they
Right.
get here. And just like the amount of what we don't know as it pertains to a black hole, I just think is a really interesting element when it comes to potential space travel. And Einstein's math within the theory of relativity in there does allow for something called an Einstein-Rosen bridge, which is essentially a wormhole, and these like holes are connected. And just the fact that like the singularity and the infiniteness and we don't know what's going on at all inside a black hole, it seems kind of a natural thought that it goes somewhere,
Right. Yeah.
which is like a very vague term, but it's like it seems
I don't know why my
entirely
brain
possible.
is so like not just dirty, but like merch specific. Where, like I just see like a picture of like that Einstein-Rosen bridge, like that diagram of it, and it just says these holes are connected. And I don't know why.
I'd wear that shirt.
Yeah,
And yeah, we're checking out a little diagram of the Einstein-Rosen bridge, the connectivity. So we're like our space time is bending, and we're essentially taking a shortcut through these.
Love
So the
it.
idea that like it's so impossible for aliens to travel this far. This is
Right.
where this kind of theory comes in. Is a shortcut essentially.
So
We're taking a little shortcut through a little wormhole.
I feel like what I'm learning here is that Interstellar is a true story.
A documentary? You mean the documentary Interstellar?
Yeah.
Yeah, that's right. That's right.
Chris
And so-
Nolan, like he dives into like awesome stuff. And,
Yeah.
like, it's all real.
Yeah,
Batman.
and it's like the black holes might be gateways to other universes.
Right.
You know, and the matter falling into a black hole, we don't know what's going on inside there, so it might create a baby universe. You know,
Right.
black holes could be universe generators. We might live inside of a black hole
The whole
created
time.
inside another universe. You know, our whole solar system and small black hole might exist inside of another larger black hole. And potentially what like we know or don't know about black holes, let's say our universe exists inside of a black hole, we're living there, just stay with me.
Okay, I'm there. I'm in it.
There might be other beings out there discussing what they don't know about the black hole that we live inside
Yeah,
of.
fuck
You know?
Yeah.
Like and I love black holes as a way. I mean, it's just such a great way to talk about this stuff, you know, in these potential theories. There's a lot of talk about potential alien civilizations utilizing the nature of a black hole as like a power plant. You know, there's infinite
yeah,
energy
Sure.
harvested
Why would we not?
in this zone. And so, you know, if you can like stay in that, you know, outside of that zone where you're getting pulled in essentially or floating across, you know, could this energy be harnessed? Something, you know, if you're capable of space travel, it's a way to essentially like maybe wait out wars, catastrophes. You go inside the event horizon and time is passing like crazy outside.
That's
and you're
me.
just like parked for a second
Yeah, I'm
while
gonna park over
everything
there.
chills out for a while.
Heck
you know,
yeah,
it's a
that's
very,
the move.
very probable or possible way the black holes could be used by alien civilizations.
And parents pointing at their children, go stand in the black hole.
Go in a black hole. That's right. And there's the Kardashev scale is like different types of civilizations and like levels of civilizations. A type 1 is able to access the energy available on its planet and store it for consumption. So that would kind of be us.
Us doing
You know, what we're up to.
electricity, water, like
Yeah.
all good,
And there's
whatever we're
a
up to.
Type 2 civilization can consume a star's energy. You know, so getting that energy from space and the things around you. And then a type 3 civilization is able to capture like all the energy emitted by its galaxy and the objects within it, stars, black holes, all that stuff. And so, you know, in our small little world on Earth, we're concerned with like energy production, consumption. And like that's just on such a small scale. And you think about
Right.
all of the limitless energy of stars and black holes and what a civilization would be able to do if they were able to harness and access that energy is just pretty wild to think about. And to your earlier point about like we're in the Milky Way, but we can see the Milky Way.
Oh yeah, tell me.
You know, I was researching earlier, and this kind of blew my mind, and it like has to do with the Fermi paradox. That's like if there's aliens, I think us at this table, we kind of have the idea that's like the universe is so big, there has to be like something out there, and probably quite a few of them. And he's like, well, then where are they?
Sounds like a dickhead.
I just felt like this was very interesting. That's like if they were doing interstellar travel, and if civilizations were able to use black holes in this way, and the black hole is at the center of gravity. Most galaxies have a black hole at the center. That's another part of this. It's not unique to our galaxy.
Good to know.
That it would stand to reason that most civilizations would be located close to that. 20-something thousand light years away from where we are. And perhaps we're in like the sticks. We're in the
Yeah.
boonies.
Yeah.
We're on the edges. So that's where everybody is or isn't, is like we're not getting visited as much to prove this stuff because we're deep. We're
Yeah.
so far out on the edge.
Right.
Yeah, we
of the
are on
Milky
like,
Way.
the rim of the Milky Way.
Because all of this action is taking place near the center of the galaxy, which is like downtown.
Yeah.
It's downtown galaxy.
Yeah, that makes
which,
sense.
Like, it absolutely makes sense.
But it's also even if like, you think about how far away the next closest solar system is, and it's just like that is an astronomical amount of
Again, we're
space.
talking light years. I can't understand.
And it's just like we look up to the sky and we think it's so full. Like it's like, oh, there's so many stars, but it's like there's so much negative space in between all of that.
I know.
Like we don't really grasp that because we're like, oh, it's just littered with stars.
Right.
And like you'll see like a star map that of like, no pollution, no light leaking,
Right,
like
right,
all
right.
that stuff. And it's just completely full. And you're like, yeah, each one of those probably has a whole system of planets around it, multiple systems of planets, like yada yada. But like it's so far away. Like every single dot of light in our sky is so far that it's like it's impossible for us to think about how far away that is.
And long ago.
I was just going to say
And how long ago
Yeah,
it is.
it's so far away and it's so long ago.
That's something that like
And it's getting
just starting
longer.
Yeah,
It's-
like
Yeah.
I'm just
I
starting
guess,
to
'cause, like,
understand
time
is
doesn't
like
stop.
we think about like all of these like all of this potential for alien civilizations kind of like right now. But think about the potential for alien civilizations in the spectrum of all the time that has ever existed. So all of the space and all of the time combined and the infiniteness of that. Maybe there's a civilization that was like identical to ours, but it like existed fucking 43 quadrillion years ago. You know?
right. Okay.
Get out of here.
And it was also like the other side of like the universe.
Yeah.
Yeah, exactly. Like the possibilities of this stuff are just so limitless. It's really hard to.
And when I
wrap
say
your
like
head around.
when I say like that the stars are getting longer and the time is getting longer, it's like the universe is expanding. So we're getting further away from those stars that we're watching burn out like every single day. We're getting further and further. So it's taking longer for that light to actually reach us. And I think at a certain point, it's going to be millions and millions of years in the future, but like eventually there's going to be no stars in the sky. Like it would have all burned out. Like, and if we wouldn't be alive, like,
Right.
like all the things will be dead by that point. But like, it'll probably get to a point where it just looks incredibly dark from the planet if the planet doesn't get destroyed by asteroids.
Sucked into a supermassive black hole.
Yeah.
Yeah, man. So that's black holes. That's everything you'll ever need to know about them and told in a perfect
Done.
narrative
Check
format.
it.
You're welcome. Yep.
How you feeling?
I feel nauseous. Is that weird? Is that normal?
I think you might have passed over the event horizon. This is early spaghettification. Is there early scientist
first
for
stage.
spaghettification? Yeah.
So whenever we do one of these podcasts, I look at what books the Conspiracy Journal has about this, because we do have 500 active titles. And so I could not find anything.
Oh, we'll have to get some people on it.
But I found one that's very interesting, which I have not read. So I would like to promote it and have people read it and call us and tell us what they think. It is called Solved: The Mysteries of Space, Time, and UFOs.
Nice. A couple times I referenced documentary. It's on Netflix. It's called Black Holes: The Edge of All We Know. It's very good.
Right
Check
on.
it out.
Right on.
It goes into a lot of the Hawking radiation stuff, a lot of the theory about black holes, but also simultaneously telling the story of the Event Horizon Telescope and
Cool.
their imaging of Sagittarius A star. So
That's fun.
if you want a little more content on that stuff, check it out. It's very well done. It's great documentary.
Right on, right on. Back to Solved: The Mystery of Space, Time, and UFOs. Do me a favor. Buy it, read it, and then call us at the Strange Exchange and tell us what you learned. 929-445-3705. That's right. I just told you to buy our book and explain it to us because I'm a dumb idiot and I can't wrap my head around any of this stuff. So please tell me what you think.
Thanks. Take care.
Thank you.
See you guys.